In today's video we will discuss about interference, that is a phenomenon which is basically shown by waves. Okay, since in this chapter we are discussing about wave optics, so light is considered as a wave, so it must show interference phenomenon. So interference, the definition I have written, that it is a phenomenon in which two waves superimpose to form a resultant wave of greater or less amplitude. In class 11 you got the concept of waves. So generally here two waves we considered, this one, two sources are there, one is S1, the other one is S2. From these two sources two waves are originating. Then these two waves, they are meeting at a certain point, suppose. Okay, this process, this phenomenon of superimposition of two waves is called interference. And due to interference, what will happen? At this point we will get a resultant displacement. Suppose the first wave, the equation of the first wave we have written like this. Okay, y1 is equal to a1 sine omega t plus kx1. y1 means it is a displacement produced by first wave in the medium. a1 means it is the amplitude of the wave. Omega t plus kx1, this is called the phase of the wave. That means, suppose if this is a wave, like this, okay, amplitude means this height. Okay, fine. Now two waves are considered here. One is this wave which is producing how much displacement in the medium, that is y1 displacement. Another wave is there, suppose this wave is the first one, so its amplitude is a1. Another wave we have, suppose this one, okay, this amplitude is this much, and that is suppose a2. Alright, now when these two waves superimpose, this one wave, how much displacement this wave is creating in the medium? y2. So when both the waves superimpose or overlap with one another, the resultant displacement produced in the medium will be, this one, y. Okay, which is nothing but it is the vector sum of y1, that means the displacement produced by the first wave, and y2, that is the displacement produced by the second wave. Okay, excuse me. So now let us see what is the phase of a wave. Suppose, just an example, this is the source of one wave, this is the source of another wave. Both the waves are reaching to this point. Okay, just a second. Suppose one wave is this, one source is this one, another source is this one, and they are reaching at a certain point, this one. Okay, so this is one wave reaching at this point, this is another wave reaching at this point. Now certainly from the figure it is clear that this wave is traveling more distance, this wave is traveling less distance. So that means they have a path difference. Their path length is not same, they have a path difference. Due to this path difference produced, both the waves will reach to this point. Okay, both the waves are reaching to which point? Reaching to this point. It may happen that one wave may reach this point by its crest. The other wave may reach this point by its trough, because we know this one, crest, trough. Okay, why it will happen? Why like this? The reason is that this is traveling less distance, this is traveling more distance, so their distance is not equal, and that is why they will have a phase difference. What kind of phase difference? Suppose if this reaches to this point by its third crest, it will reach to the next point maybe by its fourth crest or maybe fourth trough, right? They are not reaching to this point with their same number of crest and trough. Okay, once again I am telling you, suppose one source, first crest, trough, crest, trough, crest. Okay, suppose this is the position where this wave is reaching. Another wave we have, it has started from this point, it is reaching to the same point like this. So this is which this crest is first, second, third crest. For the second wave, this is 1, 2, 3, 4, fifth crest. Okay, so their crest number is different. So we will say that there is a phase difference. But why this phase difference is coming into action? Because both the waves are not moving equal distance. This is moving less distance, this is moving more distance. Or in other words, we will say that since these two waves are having some path difference because this is traveling more distance, this is traveling less distance, due to this path difference only we are getting a phase difference here. Alright, so I hope it is clear. Then let us see what happens here. Two waves we considered, they are superimposing, so their resultant becomes like this. Let us substitute y1 means this value, this one, y2 means this value. Now the thing is that after superimposition, what will be their resultant amplitude, or what will be the form of the resultant wave? This is a separate wave, this is another separate wave, they combine, they form one wave, that is the resultant wave. The pattern of the resultant wave will be like this. Why like this? That one I will tell you. Just you see here, this is the amplitude of the first wave, amplitude of the second wave, both are superimposing, they are forming a resultant amplitude, which is, suppose I am writing it by AR, R for resultant. Okay, since this is a sine wave, this is a sine wave, the resultant wave will also be a sine wave, so sine will be there. The phase I have written like this. Why like this? That one I will tell you. So two things, I told that this is the resultant wave, but in this equation, what is AR? Resultant amplitude. Okay, this resultant amplitude, somehow it is related to A1 and A2. Now how it is related, that one I will tell you. And one more thing, that in the resultant wave, this is the resultant phase, and why it is like this, that one also we will discuss. Alright, okay. Now since we are talking about vector sum, this one is nothing but vector sum, so we have to follow the vector summation rules, parallelogram law or triangle law of vector addition. So resultant AR, this is the resultant of which two vector? A1, A2. So I have drawn here, suppose this is A1, this one is A1 vector, this one is A2 vector. Okay, now A1 is this wave, A2 is this wave, right? What is the phase difference between them? Here I have written this one. Phase difference will be always in terms of angle. Okay, angle difference. So phase difference means this one minus this one, because this is the phase. Okay, so this phase minus this phase will give us phase difference, which is generally denoted by phi. Okay, so this minus this, if we do omega t get cancelled, we get this one, and from this x2 minus x1. Now what is x2? X2 means it is a displacement, this much displacement produced, or it is traveled by wave 2, this wave, and x2 is this much distance, the distance traveled by wave 1. So x2 minus x1, that gives us path difference in the path traveled by both the waves. Okay, k is called wave number, the value of k is 2 pi by lambda. Okay, angular wave number. Anyways, so phi is equal to, k means 2 pi by lambda, and x2 minus x1 means I have written in delta x. So delta x is path difference, phi is phase difference. Alright, okay. Now a1 I told that this vector, a2 is this vector. What is the phase difference between them, or what is the angle between them? Phi. So that is why this angle between them I have drawn it as phi. Okay, now if you remember class 11 parallelogram law of vector addition, there the resultant is like this. This is the diagonal of the parallelogram. If you complete this parallelogram, it will be something like this. Okay, right? This is the diagonal of the parallelogram, that is AR. So we had this formula, if you remember, resultant square equals to a1 square a2 square plus 2a1 a2 cos of phi. Okay, so AR will be root over this value. Okay, so in the resultant expression, here we have written AR, so this AR is nothing but this value. Okay, how the resultant amplitude AR is related to the amplitude of first wave and second wave? By this formula. Okay, now this amplitude will be the maximum, or the resultant amplitude will be the maximum, is if cos phi becomes 1, because the maximum value of cos phi is 1, right? So if this is 1, what will be the form of the equation? Like a square plus b square plus 2ab. That means it is a plus b whole square. That means it is a1 plus a2 whole square under root. So root and square will get cancelled. We will get this value a1 plus a2. I have written here a max. A max means it is the maximum value of resultant. Okay, resultant of amplitude. Next, if it is the minimum amplitude, for minimum amplitude the value of cos phi will be minus 1, because the cos phi, the range is from minus 1 to plus 1. So minus 1 is the minimum value. If it is minus 1, under root we are getting a1 square plus a2 square minus 2a1 a2. So this is in the form a1 minus a2 whole square. So this whole square and this square root will get cancelled. We are getting a1 minus a2. So this is the minimum resultant of what? Of amplitude, or we can say minimum amplitude. Okay, then this part AR we got. AR means this value. Alright, this one, see here, since both the sine waves are superimposing, sine will be there only, but yes, phase difference, why we have phase, not difference, phase, why I have written like this, omega t. See, omega t is common for both, for this as well as for this, so there will be no change in this. Okay, plus this value, where did I get? Okay, where is the resultant amplitude? This is the resultant amplitude. This resultant amplitude, how much angle it is making with a1? A1, suppose theta angle it is making with a1. So when I am writing here AR, that means I am talking about this resultant. Okay, how much more angle it is making then from a1, because a1 is making how much angle? Omega t plus kx1, this one. Okay, then the resultant is making theta angle more than a1. So for a1 this value we will have. For a1 this value we will already have, but theta, why we have written theta? Because this time this is our resultant, so if this is our resultant, it is ahead of theta angle from a1, so a1 will remain as it is, plus there will be theta angle. Okay, now what is the value of theta? See, if you remember the parallelogram law of vector addition, this part, okay, this is the resultant is making theta angle with one of the vector, then tan theta is equal to this type of formula you got in vector addition law. It was I think there it was p sin theta by p plus q plus p cos theta. It was something like that, because the vectors were named pq probably, but here the names of the vectors are a1 a2, so it comes like this. Okay, fine. So if you have any doubt, you can just check your class 11's copy, this part. Okay, then this much is done. Next, let us discuss intensity. Okay, intensity. Now suppose we are finding intensity of what? Intensity at this point, because two waves are meeting at a particular point. We have to find out what is the intensity of resultant at that particular point. So what we have is, we have a relation like this: intensity I is equal to some constant k into amplitude square. Okay, from this we can write amplitude square is equal to intensity by that constant. If it is so, this condition we can apply here. If we do so, here means, okay, in the first, this equation, okay, we are applying it in equation A, this one. So in equation A, AR square, like A square equal to I by K, AR square will be IR by K. IR means what? R means resultant intensity. Okay. Similarly, A1 square will be I1 by K. A2 square will be I2 by K. Fine. Plus 2 as it is. A1 means what it should be. Here A1 means, A means what? What is that? Root over I by root over K. Because A square is I by K, so A will be root I by root K. If it is A1, then it will be root I1 by K. If it is A2, this one, then it will be root over I2 by K and cos phi. I hope it is clear. Okay. Now see, this K gets cancelled. Root K, that also gives us what? K only. So that will also get cancelled. What we are going to get is this value. Okay. So this is the IR is the resultant intensity. That means the intensity produced by superimposition of both the waves. This is the thing. Okay. And and maximum value of IR means maximum intensity. It will be achieved if cos theta is 1 plus 1, and minimum intensity will be achieved if cos theta is minus 1. So when cos theta is plus 1, certainly this thing will be 1, no? So we will get I1 plus I2 plus 2 root I1 I2. Now I1 means, can we write it root over I1 whole square? Similarly, I2 means we can write root over I2 whole square. If we write so, this will be in the form a square plus b square plus 2ab, because cos theta is 1 only for maximum case. So it will be a plus b whole square. Okay. And for minimum case, cos theta will be minus 1. So if it is minus 1, here we will get 1 minus. So that means it is in the form a square plus b square minus 2ab. So it will be a minus b whole square. So this is the maximum intensity, minimum intensity. And condition for maximum and minimum intensity is that cos theta, once it will be 1, once it will be minus 1. Now another very important thing, maximum intensity means, we call it constructive interference. Means, suppose if we consider two light waves, particularly we are specifying that these two waves are light wave. Okay. If it is light wave, if they are meeting at this particular point, and if their intensity, and if they are making maximum intensity at this point, that means this point will be a bright point. We call it constructive interference. Okay. If both the light waves are meeting with a minimum intensity, then this point will be a dark point. Minimum intensity means zero intensity, dark point. If it is a dark point, we call it destructive interference. Okay. Constructive interference means bright, destructive means it is dark. Okay. Now let us see the conditions for constructive and destructive interference. Already you okay, already from here you got this one, that intensity maximum will, okay, just a second, intensity maximum will be achieved if cos phi is 1, right? That means cos phi is equal to plus 1 is the condition for constructive interference. Cos phi is minus 1, this is the condition for destructive interference. Let us discuss it here. I have written the conditions. Constructive interference cos phi is +1. Now if cos phi is +1, from trigonometry you got this concept. Cos phi +1 means it is cos 2n pi, means cos 2n pi is equal to +1, where n starts from 0, 0, 1, 2, in that way till n. This is an integer. Okay, if it is so, cos will get cancelled, we get phi equals to 2n pi. That means if phi means what? Phase difference. If the phase difference is 2n pi, then it will be a constructive interference. Now if phase difference is this, what will be the path difference? Because phi means it was k delta x, right? In last page you got this one, phi equals to k delta x. K means 2 pi by lambda delta x. Okay, so here in place of phi I have written this one, 2 pi by lambda delta x. From this 2 pi get cancelled, we get delta x equals to n pi. So delta x is a path difference, where path difference is n pi, n starts from 0. So this is the condition for constructive interference in terms of phase path difference, and this is the condition in terms of phase difference. Okay, destructive interference, cos phi will be -1. If cos phi is -1, cos phi becomes -1 for this value, cos twice n -1 pi, where n starts from 1. Okay, cos get cancelled, phi equals to this. This is the condition for destructive interference in terms of phase difference. In terms of path difference, in place of phi we should write this value, just like this. Okay, just a minute, there is a mistake. Okay, this is phi, this is not phi actually, this should be delta x, just like this. Okay, make it delta x. Here also same thing, this is not phi, this should be delta x. So delta x is twice n -1 lambda by 2. Okay, n starts from 1 to 3, I mean from 1, right? So we got these conditions here for constructive and destructive interference. Okay, so for today, for this video, this much only. We'll discuss Young's double slit experiment in the next video. Thank you.